Hello. In this presentation, we describe the co-speech gesture generation system developed by the DSI team for the GENEA Challenge 2022. In our proposed framework, it features a unique hybrid encoder-decoder architecture based on the transformer network for the encoder and recurrent neural networks, specifically LSTM for the decoder. Here we describe our encoder in more details. Our encoder is based on the original transformer network's encoder architecture that utilizes the multi-head self-attention mechanism, which was shown to be effective in capturing hierarchical representation from sequential data. Our encoder takes as an input the audio features extracted from the raw audio of the speech, which in our case was MFCC and MFCC delta. The encoder in return is responsible for transforming the input audio features A into a latent sequence Z. The encoder internally, as it can be shown from the figure, consists of a number of blocks, where in each block it contains a feed-forward neural network and a multi-head self-attention operation. In total, we have 2 blocks inside our encoder. Here we move to the decoder part, which takes as an input both the latent sequence feature Z from the encoder module, and during the training phase it also takes as an input the ground truth co-speech gesture motion from the full body in 3D. For our decoder architecture, we choose to utilize the LSTM architecture, as it was shown in previous works to be quite effective when it comes to capturing the spatiotemporal dependencies between consecutive gesture motion. In total, as part of our decoder, we have 3 LSTM layers in addition to 1 linear layer, which is used to autoregressively predict a sequence of full bodies 3D gesture motion. Since the duration of each speech recording in the challenge dataset is variable, the first preparation step we started with is segmenting each recording into smaller chunks to facilitate the training process. And instead of doing this segmentation using a sliding window style, we utilize the transcripts that was provided as part of the challenge to roughly segment the starting and ending times of sentences. Given that the transcripts provided were on a word level rather than sentence level, so we heuristically have constructed a sentence based on joining consecutive words based on their timings. We further filtered out long sentences to have all sentences under 30 seconds for an efficient training. Regarding the gesture motion data, they were represented by flattened translation and rotation matrices of the 56 joints of the full body. Since one of the challenges that autoregressive models are faced with is the accumulation of prediction errors during the inference stage, so in order to overcome this challenge, we adopted a curriculum learning strategy during the training of our framework. This strategy dynamically during the training process alternates between the fully guided teacher forcing paradigm and the less guided autoregressive paradigm. Now we evaluate the performance of our framework, FSF, according to the challenge subjective evaluation metrics. Here the first evaluation metrics is the human likeness. As it can be noticed, our framework was one of the top 4 systems that have achieved the highest level of human likeness. Here we show the performance according to the other subjective evaluation metric, Appropriateness. In this metric, our proposed framework seems to be lagging despite the fact that it's on par with the other participant systems when it comes to the preference of the subject to the matched motion. Here we further evaluate the performance of our system according to a number of objective evaluation metrics. As it can be noticed, our system FSF is one of the top 2 systems that are closer to the natural motion system FNA in terms of average jerk and acceleration, and one of the top 3 systems when it comes to global CCA score. Here we show some qualitative sample of the generated full body motion of our proposed framework.
I can tell you something that did happen to me, and this is the worst thing that's ever happened to me, so I'll tell you this. At a pirate game, I had bought, at my first job out of college.
For our future work, we would like to investigate feeding a raw speech directly without feature extraction to our encoder. We would like also to investigate and explore the feasibility of unifying the encoder-decoder architecture to be fully transformer-based. Thank you.